All right, now you're going to have to verify trig identities. And essentially what that means is you have to verify that this side right here equals this side, or vice versa. You can start on either side. Typically, problems are set up where you work on the left until it equals the right side, but you can go either direction. Here is a tip. It's sometimes very handy to use other trig identities. So every time you see a tangent, you might want to convert it to sine over cosine. Or when you see any of these Pythagorean theorem varieties, I just started to spell that oddly. That's not good. To use those identities to substitute. So let's get started. So here, right here, we have 1 subtract secant squared x over secant squared x is equal to negative sine x. Well, this looks pretty familiar. I have a secant squared x. Oh, look it. If I subtract 1 from both sides, secant squared x subtract 1 is equal to tangent squared x. And then I could turn that into that. Ooh, I'd maybe be getting closer. But this says 1 subtract secant squared, and that says, so if I multiply this whole side by negative 1, I would then need to multiply this whole side by negative 1. When I do that, negative 1 times 1 is negative 1. And negative 1 times negative secant squared x is positive secant squared x. So those two things just reverse. And then negative sine squared x times negative 1 is positive. So far, that's all I've done is I've multiplied both sides by negative 1. And now secant squared x subtracts 1 is equal to tangent squared x. So I'll come down here and see if that's what I did. I did. All right, now I can rewrite these as 1 over secant squared x and then tangent squared x over 1, and that's multiply. And then tangent squared x can be converted to I went ahead and wrote it as a fraction. I could have written them side by side of each other, but let's go ahead and how I did it this way. Here's the mistake I would have made doing it that way. Secant is under here, so secant is the same as 1 over cosine squared x. All right, so I went ahead and wrote tangent squared x as sine squared x over cosine squared x, and I wrote secant squared x. I just changed secant squared x to 1 over cosine squared x. Well, we don't want a fraction over a fraction, so I'm going to multiply cosine squared x over 1. Do the same thing up here. Those cancel. And what you have left is sine squared x is equal to sine squared x. But remember, at the very beginning, we multiplied everything by negative 1. We have to multiply everything by negative 1 again, because we have to put it back in its original form. So we have negative sine squared x is equal to negative sine squared x. Check. All right, let's come over here. Do another one. So we have cotangent x plus tangent x is equal to cosecant over cosine. Well, cotangent and tangent can just be rewritten as cotangent is cosine over sine, tangent is sine over cosine. Here's two fractions being added, so we would need to, before we can add these, they need to have the same denominator. So we have to multiply this one by cosine x over cosine x. And then we have to multiply this side by sine x over sine x. And then look at what we have. Cosine times cosine. That's going to cancel to cosine squared x. That's going to cancel, or condense, not cancel, condense. We can rewrite it as sine squared x. And remember, when you add fractions of the same denominator, you can just combine the fraction into 1 because they'll have the same denominator. And then look at what we have in the numerator. Cosine squared x plus sine squared x. Well, what does cosine squared x and sine squared x equal? It equals 1. So we're going to be able to cancel all of this and put a 1. That's what I did. And then look at, those could be rewritten. We could write 1 over sine times 1 over cosine, because these two things are being multiplied. So if you separate it out, you just separate it like this. And now we can use other trig identities. Look at 1 over sine is the same as, cosecant, which is what I have right here. And then I left cosine in the denominator. Oh, look at, the left side equals the right side. Check. So there we go. That's it for this one. Verifying trig identities.